the multiverse. The possibility that our universe is just one of an infinite number of universes.
Whoa!
That's Michio Kaku.
Yeah,
And honestly, that's a pretty wild concept to kick off this deep dive with.
it is.
But that's exactly what we're looking at today. You've sent in a whole stack of articles about the multiverse, everything from basic explanations to the latest research.
And it seems like everyone's got an opinion on this. From mainstream science publications to big-name physicists, the multiverse is a hot topic.
It really is.
Yeah.
But before we get ahead of ourselves, let's define what we mean by the multiverse. Because let's be real, it's not just about hopping between realities like in the Marvel movies, right?
No, not quite. We're talking about something far grander, something that delves into the very fabric of reality. The multiverse, in a scientific context, suggests that what we perceive as the universe might actually be just one of many, possibly infinite universes.
Okay, so multiple universes. It's a mind-bending concept, and it's not exactly new. Philosophers have been wrestling with this idea for centuries. But what's fascinating is that modern physics seems to be lending some weight to this once purely theoretical notion.
Exactly. It's not just philosophical pondering anymore. There are aspects of our current understanding of physics, particularly in cosmology and quantum mechanics, that seem to hint at the possibility of a multiverse.
And one of the biggest drivers behind this multiverse theory is something called the fine-tuning problem.
Right.
It kind of makes you feel like our universe is the ultimate lottery winner.
In a way, it is. The universe as we know it is governed by a set of fundamental constants. The strength of gravity, the speed of light, the universal settings. And these constants seem incredibly, almost unbelievably fine-tuned for life to exist.
Yeah, you mentioned the Science Museum blog earlier.
Yeah.
It says, if gravity were just a bit stronger, stars would burn out before life had a chance to even spark.
Right.
It's like the universe knew we were coming.
That's a very simplified way of putting it, but you're right. Even a tiny tweak to any of these constants and the universe as we know it wouldn't exist. Stars, planets, even the very atoms that make us, none of it would be here.
So what are the chances? It's like finding a needle in a haystack. Actually, it's more like finding a specific grain of sand on a beach.
The odds are astronomically small, and that's where the multiverse theory comes in. Instead of one universe where everything just happened to be perfectly calibrated for us, the multiverse suggests that there could be countless other universes, each with its own set of constants. So, statistically, it makes sense that at least one universe, ours, would have the right conditions for life.
So rather than being an incredible fluke, our universe is just one possibility out of, well, an infinite number of possibilities. It's a way to address those seemingly impossible odds.
Precisely. And, the idea that the laws of physics could be different in other universes isn't just some wacky consequence of the multiverse. As early as 1973, physicist Brandon Carter was already talking about this anthropic principle, the idea that the universe is fine-tuned for life because we're here to observe it.
Okay, so we've got these mind-boggling constants that seem perfectly set for us. We've got this idea that maybe we're not so special after all, just one universe in a sea of possibilities. And now we're talking about different universes with different laws of physics.
Exactly. And the implications of that are truly astounding. Imagine a universe where gravity is weaker, where you could jump buildings in a single bound, or a universe where light travels at a snail's pace.
You're saying there could be a universe out there where I could dunk a basketball? Sign me up. But seriously, this is where things start to feel less like science and more like, well, science fiction.
I understand where you're coming from, but that's the beauty of the multiverse theory. It takes us to the very edge of what we thought was possible and forces us to reconsider everything we thought we knew about the universe.
And, speaking of pushing the boundaries of what's possible, there are actually different types of multiverses that physicists have proposed. It's not a one-size-fits-all kind of concept.
It's more like a buffet of cosmic possibilities. You're right, it is a buffet of possibilities. And one of the most popular items on the menu is the cosmological multiverse. This one comes from the idea of cosmic inflation, that period of rapid expansion right after the Big Bang.
Yeah, that crazy growth spurt the universe went through. But in our universe, at least, that had to have stopped at some point, right? Otherwise, we'd all be thinner than a pancake right now.
Exactly. Think of it like a balloon being inflated. In our region of space-time, that balloon stopped inflating and settled into a more stable state, allowing stars and galaxies to form. But what if, and this is where the cosmological multiverse comes in, what if inflation never actually stopped completely?
So instead of one balloon, we got a whole bunch of them, all inflating at different rates, even popping up in new and unexpected places.
That's the general idea. This concept is known as eternal inflation, and it was actually pioneered by physicist Andre Linde. Essentially, eternal inflation suggests that inflation is still happening in other parts of the cosmos, creating a constantly expanding canvas of space-time where new bubble universes are constantly popping up.
Wow. So our universe is just one bubble in an infinite cosmic bubble bath. That's both comforting and terrifying at the same time.
That's a great way to put it. And here's the really mind-blowing part. Each of these bubble universes could have its own set of physical laws and constants. So while gravity might be a drag in our universe, it could be a breeze in another.
I'm imagining myself floating from planet to planet like a cosmic Mary Poppins. But the BBC article also mentioned something about black holes being connected to other universes. Is that another cosmological multiverse theory?
It is. This one is a bit more speculative, but physicist Nikodem Poplawski has proposed that new universes might be born inside black holes.
Wait, so instead of everything getting crushed into oblivion at the singularity, you're saying there's a whole other universe on the other side?
That's the idea. Imagine falling into a black hole. As you approach the event horizon, the point of no return, instead of being crushed, you emerge into a whole new, expanding universe.
Okay, now that's just showing off. But seriously, if we can never escape a black hole to tell the tale, how could we ever test this theory? It seems a bit far-fetched, even for a multiverse idea.
You're right to be skeptical. It is highly speculative, but that doesn't mean it's entirely outside the realm of scientific inquiry. There are some theoretical ways we might be able to find evidence of these black hole universes. Remember that article from the Science Museum blog?
The one about the cosmic microwave background radiation, the afterglow of the Big Bang?
Exactly. Some physicists believe that if our universe collided with another in the distant past, maybe even one that emerged from a black hole, it might have left an imprint on that radiation.
So we're looking for cosmic bruises, scars left over from our universe bumping into another.
Something like that. Of course, finding and interpreting those signals is a monumental task, and so far, we haven't found anything conclusive.
Well, while we're waiting for those cosmic detectives to do their work, let's move on to another type of multiverse on our buffet. The quantum many worlds interpretation. This one always gets me thinking about all the different paths my life could have taken.
It's definitely a thought-provoking concept.
Yeah.
The quantum many worlds interpretation emerges from the world of quantum mechanics, specifically the idea of superposition.
Superposition.
Oh.
This is where things start getting really weird, right? It's like that whole Schrodinger's cat thought experiment.
Exactly. Remember that BBC article that explained it as a cat being both alive and dead until you open the box?
Right.
That's superposition. It's the idea that a particle can exist in multiple states at once until it's measured.
Okay, so how does a cat in a box lead us to a whole multiverse?
Well, the many worlds interpretation takes this idea of superposition and applies it to the entire universe. Every time a quantum measurement happens, every time a particle has to choose a state, the universe splits, creating a separate branch for each possibility.
So there's a universe where the cat's alive, one where it's not, and I'm guessing infinite universes in between.
You're getting it. Instead of one reality, the many worlds interpretation suggests a constantly branching reality, an infinite web of possibilities where every single quantum measurement spawns new universes.
I've got to admit, that's a bit much to wrap my head around. So somewhere out there, there's a version of me who decided to have pizza for breakfast this morning instead of oatmeal, and another where I'm a rock star.
It's a fun thought experiment.
Yeah.
This interpretation suggests an infinite number of yous out there, each having made different choices, experiencing different outcomes.
I think I need to lie down after that one. You know, we haven't even gotten to string theory yet, and that one always feels like the most mysterious of all.
It's definitely a complex theory. The basics aren't too hard to grasp, though. Imagine that everything in the universe isn't made of particles, but of these tiny, vibrating strings.
Vibrating strings, like those rubber band bracelets we used to wear as kids?
Well, a bit smaller and much more energetic. And just like different vibrations on a guitar string produce different notes, different vibrations of these strings create different particles and forces.
Okay, so far so good. But you mentioned that string theory needs extra dimensions, right?
Yeah.
Not just the 3 spatial dimensions in time that we're used to.
That's right. String theory only works mathematically if there are more dimensions, maybe 6 or 7 more. But don't worry, we're not likely to bump into them anytime soon. They're thought to be curled up at an incredibly small scale, far beyond what we can observe directly.
Curled up dimensions. I'm trying to picture that. So where do these extra dimensions fit into the whole multiverse idea?
Here's where it gets really interesting. Brian Greene, in that NPR interview you shared, described how these extra dimensions could be home to other universes.
Like hidden pockets of reality tucked away in these curled up dimensions.
In a way, yes. Imagine our universe as a flat sheet, what string theorists call a brain, floating in this higher dimensional space. Now imagine other brains floating out there too, each representing a separate universe.
So instead of bubble universes, we've got brain universes. I'm starting to see a theme here. Lots of different containers for these hypothetical universes.
It's a whole cosmic storage unit. But in all seriousness, you're right. The multiverse takes many forms depending on which theory you're looking at. And importantly, not everyone is convinced by these multiverse ideas.
Yeah, it's not like everyone in the scientific community is on board with the Multiverse Express.
Not at all. In fact, there's a lot of debate around it. Some argue that the multiverse is untestable and therefore not truly scientific. That Scientific American article you sent mentioned George Ellis, a pretty vocal critic of the multiverse.
Because if we can't observe these other universes, how can we ever prove or disprove their existence?
Exactly, it's a valid point. Some physicists argue that invoking an infinite number of universes to explain the one we see is a step too far. They prefer to stick with what we can observe and measure directly.
Occam's razor and all that, the simplest explanation is usually the best.
Precisely. But then again, others argue that a multiverse is actually a more elegant solution to some of the biggest mysteries in cosmology.
Mysteries like that whole fine-tuning problem we talked about earlier.
Exactly. They argue that while the multiverse might seem complex, it offers a more parsimonious explanation for why our universe seems so perfectly suited for life.
It's almost like a philosophical debate disguised as a scientific one. So what does this all mean for our listener? Where do we go from here?
Well, I think the most important takeaway is that the multiverse, while still theoretical, is a powerful reminder that our understanding of the universe is constantly evolving.
And that there might be far more to reality than meets the eye. Who knows, maybe one day we'll have the tools to peer beyond our own cosmic backyard and finally answer the question, are we really one in many?
Until then, it remains one of the most intriguing questions in science.
It really does. And hey, thanks for taking this deep dive with us. We'll see you next time for another exploration of the biggest ideas in science.